Good day, grade 11 learners. Welcome to today's technical mathematics and revision lesson. My name is Nyasha Chloride Gwangwaza. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pakama Research and Development. Right, grade 11 learners, before we start the lesson, please make sure that you have a pen and paper ready, as well as your calculators, so that we work together as we go through this revision lesson. Our lesson today is going to be exponents and surds. Exponents and surds is part of our algebra, paper 1. And algebra, as you all know, is the central part of our mathematics. It is applied in all other subject areas. So you really need to know how to work with algebra before you can venture into the other topics. Today's focus is exponents and surds, like I explained before. Under exponents and surds, you are expected to know how to add, subtract, multiply, and divide simple surds. And then you also need to know how to apply the laws of exponents to expressions and equations involving rational exponents. Remember, when we say rational exponents, we are looking at fractions. So we have an exponent which is a fraction, and for a fraction, remember, the denominator cannot be 0. That is what we're explaining by q should be greater than 0. And the base of our exponent as well should not be a 0. It should be greater than 0 for us to be able to work with exponents and surds. Right, in our next slide here, you can see the different ways in which we represent our terms or numbers. X multiplied by x can be written in short as x raised to the power of 2. And if at times you want to be a little bit complicated, we can change this to a surd by writing the half root of x. And this triangle here also shows a different way in which we can express 8 raised to the power of x. 8 raised to the power of x can also be written as 128 to the power of the square root of x. Right? Some of you are already wondering, what is this all about? So before I continue, let me start by defining what a surd is. A surd is a rational number that cannot be determined exactly. Right? When we're saying it cannot be determined exactly, if you look at your calculator, you take the square root of 2. The square root of 2, when you punch in onto your calculator, if you do that quickly, it will give you a decimal number, which is 1,414, and the decimal continues. That's what we mean we cannot find the exact value of the square root of 2. Same as if you look on your calculator, check the cube root of square root 21. I know all of us by now should be able to use the calculator to find the cube root of 21. Again, the cube root of 21 will give you the number 2,75, and it continues. The same with the square root of 27. It also gives you a non-terminating decimal. The square root of 27, if you check on the calculator, gives you 5,196, and it also continues like that. So when we are working with such numbers, at times it would be easier for us to just write it in surd form than for us to write it in a decimal form. Now, like in any other area in life, we need rules to make our lives easier. So we are going to start with surds and look at the different ways in which we can use surds to simplify our lives. The first surd rule that I have here, when we are multiplying two surds, the square root of a multiplied by the square root of b can be simplified to just say the square root of a times b. Now, what do I mean by that? We are simply saying if you take your calculator and punch in square root 2, then multiplied by the square root of 3, your answer will simply be square root of 6. Now, where did that square root 6 come from? This comes from multiplying the two numbers that we had there under the root sign, root 2 times root 3. So we just take the 2 and 3 and multiply it together. That gives us a 6. Right. The second one, if we are dividing two sets, we are looking at the square root of 2 divided by the square root of b. If I need to simplify this, I can just shorten it and write the square root of a divided by b, all under the square root sign. And then this simplifies our lives, because at times you may find, for instance, if I have square root of 20, if you check on your calculator, square root of 20 does not give you an exact value. So if I need to simplify square root of 20 divided by square root of 10, the simplest way that I can do this is by first dividing 20 by 10. And when I divide 20 by 10, I get the square root of 2. Now, this is the simplified form that I would have after I have divided square root of 20 by the square root of 10. The last rule that we are going to look at is when we are multiplying a set that has the same term under the root sign. So if I have square root of a times square root of a, my answer will simply be what is under the square root sign. So if you take your calculator, you punch in square root 7 multiplied by the square root of 7, you'll see that your answer will simply come to this to the answer 7. So instead of wasting time to try and figure out what is going on here, we can just write this as the square root of 7. But please take note, grade 11s, when we are working with sets, sets can also be written as exponents. That's the reason why you see we have included sets and exponents in the lesson. If I have the square root of a is the same as writing a raised to the power of a half. Where does this a half come from? Right. If you check under the root sign, we have a. The exponent of a there will be a 1. And on the radical sign, which is the root sign, I do not have any number, but when you see this, we all know that the number that we're supposed to have there is a 2. So when I'm trying to simplify this or change the form in which I have written square root of a, I take the base, which is the a, and then I raise this to the power of the exponent of the a under the radical divided by the number in front of the radical. In our case, it's square root, so it will be divided by 2. If I had the cube root or the 8th root, let's use the 8th root. I'm looking at the 8th root, say for instance, of 5. This will change to 5 raised to the power of, I know you all of us probably already said this is 5 raised to the power of 1 over 8. Now let us look at a few examples that we'll need to be able to work on our activities. Right, the square root of 5, if you check on your calculator quickly, this is already simplified enough, so there's nowhere else we can simplify it further, just the same as square root of 10. But if I have square root of 27, on my calculator, square root of 27 gives me 3 root 3. How did we come about 3 root 3? Well, the first thing is I need to first write 27 as a product of factors, where one of the factors is a perfect square. But some of us find it very difficult to look for these factors because we end up having to divide so many times to get to the solution. So say for instance, I've forgotten how to find these factors. First take your calculator, punch in square root 27. Then this gives you 3 root 3. Then after you have found your 3 root 3, you do not write the solution first. You're going to expand 27 to a product of factors. What are the factors? Remember, there is a 3 outside, so you are going to write the 3 as a repeated factor under the square root sign. Then you write the 3 that is already under the root sign. So this is the same as saying the square root of 3 multiplied by 3 multiplied again by 3. But remember, 3 times 3 gives us 9. Where 9, as we all know, is a square number. So when I'm simplifying this, at times if I find it difficult to find the factors quickly, I just quickly take my calculator so that I can quickly get those factors. But please make sure that when you are doing this, you show all the working. Right, let us move on to the next one, square root of 72. Right, square root of 72 is the same as writing it as a product of two factors, which is 36 multiplied by 2. Right, another hint that I can give you here is if I have an even number, we all know that even numbers can be divided by 2. So first check by dividing quickly the number by 2. 72 divided by 2 is 36. And fortunately, 36 is a square number. So we know that we can find the square root of 36. And the square root of 36 is 6 root 2. The last example there, we have the last one there, we have more than one term under the root sign. We have a number before the root sign. So if we have a number before the root sign, please be careful. You need to make sure that when you are simplifying that number outside there, the 2 there, means I'm multiplying 2 by the root sign. And then when I simplify, I first work with what is under the root sign. So if I need to write this as a product of factors, the highest square number that I can use as one of the factors is 4. So 40 becomes 4 multiplied by 10. And then when I simplify this further, the square root of 4 is a 2, but the 2 is going to be multiplied by the 2 that was already outside the bracket. Then the 2 times 2 gives me a 4. And since square root of 10 cannot be simplified further, I leave it under the square root sign. Now, let us look at the examples of the type of questions that you'd probably meet in exams. The first example here has a combination of 2 operations. The first one is subtract. Then after subtracting, there is this division line. So it means that when you have something like this, the easiest way to simplify is to first make sure that you work with what is in the numerator first before you go and divide by the factors in the denominator. Right, so quickly, if we check again, the square root of 48, the square root of 48 as a product of factors becomes 16 multiplied by 3. Then after that, I'm subtracting the square root of 12, and the square root of 12 as a product of factors becomes 4 multiplied by 3. And then this is going to be divided by 2 multiplied by the square root of 75. But remember, square root of 75 also needs to be simplified. So I'm going to change 75 to a product of factors. And as a product of factors, this becomes 25 multiplied by 25 multiplied by 3. Now, when I try to simplify this further, the square root of 6, the square root of 16 becomes 4. So in my fraction there, I am going to have 4 root 3 minus, it's going to be minus 2 root 3. Then in the denominator, I'm going to have 2 multiplied by 5 root of 3. right? And when we try to simplify this further, I am going to have 4 root 3 minus 2 root 3 divided by 10 root of 3. And then when I simplify this further again, you'll find that we can divide the square root 3 by the square root 3, and this gives us 2 over 10. Now the 2 over 10 will simplify to 1 over 5. I hope you were able to follow through grade 11s, and you also verified with your calculator if this will give us exactly what we are talking about. Right, so let's quickly check again. We said 4 square root 3 minus 2 square root 3. And then this is divided by 2 multiplied by 5 square root of 3. Then, like I said before, this gives us 2 root 3 divided by 10 root 3. Then the root 3's will divide, then this gives us 1 over 5. I hope you were able to follow that through grade 11s. Looking at the next example, our next example is a bracket multiplied by a bracket. And if you check, we have 2 terms in both brackets. So we are multiplying a binomial by a binomial. But if you look closely again at these 2 brackets, you will notice that we have the same factors. We have 4 square root 5 there, another 4 square root 5 in the second bracket. Then we also have square root 2 in the first bracket, followed by square root 2 in the second bracket. But the signs in the 2 brackets are different, meaning that we can call this a difference of 2 squares because the brackets are exactly the same besides the sign. So I'm going to try and rearrange the first bracket because when we know that when we are multiplying a difference of 2 squares, there is a certain rule that we can use to make sure that our work is simplified. So I'm going to rewrite the first bracket as square root 2 plus 4 square root 5. Then this is multiplied by square root 2 minus 4 square root of 5. Now, when I'm multiplying a difference of 2 squares, we all remember, yes, that we can take the first term multiplied by the first term in the second bracket. So remember, square root 2 multiplied by square root 2 gives us simply a 2. You remember that rule we talked about where we said if we are multiplying the same root or same term under the root sign, our answer is simply what is under the square root sign. Then after we have done this, we need to multiply the second term in the first bracket by the second term in the second bracket. So when we multiply a positive 4 square root 5 by a negative 4 square root 5, this becomes a negative 4 multiplied by 4 is 16. Then square root 5 multiplied by square root 5 simply gives us a 5. Then as we go further, 2 minus 16 multiplied by 5. Remember the order of operations. I need to make sure I multiply first before I subtract. So 16 multiplied by 5 there gives me a 80. And then when I subtract these two, my answer there will be negative 78. I hope that we are all following through this. And remember, if you have any questions, we still have our WhatsApp number 079 578 2908. Please post your questions there so that we can clarify any point where you do not understand. Right. Moving on to the third example. Here we have also quite an involving question. We have 2 terms in the numerator. We also have 2 terms in the denominator. Now we need to be very careful. Remember, when we are dealing with fractions, we cannot just simply cross out or divide numbers if there are two terms. We need to first make sure that we have either factorized so that there is a common factor, or we can quickly make sure that we simplify the numerator and all the denominator before we can continue. So if you look at our next example, like I'm saying, it is quite involving because we've got two terms in the numerator and two terms in the denominator. So we need to be very careful here. So the first thing that I'm going to do is we are going to simplify the square root of 20. Now remember, when we're simplifying the square root of 20, we need to write it as a product of factors. And I think by now you are very familiar. We need to make sure that one of the factors is a perfect square. So the perfect square there that we're going to use is 4 multiplied by 5. And then when we move further, we are no longer looking at the square root, but now this is the cube root of 8. Now cube root means we need to look for a number that multiplies itself 3 times to give us 8. And those who have checked on their calculator have seen that cube root of 8 gives us 2. So it means that I need to write 2 as a repeated factor, under the root sign. And then in the denominator, I cannot simplify further, so I'll simply write it again as square root of 5 minus 1. Now the square root of 4, like I indicated before, is a number that multiplies itself to give us 4, which is 2. So this simplifies to 2 square root 5 minus, remember, cube root of 8 is 2. So I simply write it 2, and this is divided by the square root of 5 minus 1. Now, some of us are probably saying we can't continue. But if you look carefully again, I have a square root 5 in the numerator, I have a square root 5 in the denominator. So something must be happening here. I think if you check carefully in the numerator, we have 2 in the first term. I have another 2 in the second term, meaning I can factorize the numerator. So if I factor out this common factor, which I've just found to be 2, I'll end up with 2, and in the bracket, I'll have square root of 5 minus, remember, I took out a 2, so I want a factor which I multiply by 2 to give me 2, and we all know that factor will be 1. And then this will be divided by the denominator, which is still the same, square root 5 minus 1. Now, what do we notice, grade 11s? We have square root 5 minus 1 as a factor in the numerator. We also have square root 5 minus 1 as a factor in the denominator. So these two can be divided. And when I divide these two, I'm going to end up with just 2 multiplied by 1 in the numerator. And this is divided by 1. And my solution there will simply be a 2. I hope we are able to follow this through. Now it is your turn to try and apply all those skills that we have been talking about. So I'm going to give you 3 minutes to look at these 3 examples and try to work them out as quickly as possible before we look at the solutions. Welcome back, grade 11s. I hope you have had enough time to look at the questions and you have the solutions ready to check if we have done it well. The solution for the first one, we had 3 square root 5 plus 2 square root 5 minus 5. Now, this is a simple addition and subtraction question. And remember, when we are looking at sets, we can treat them the same way as when we are working with our algebraic terms. We have 3 of the root 5s, then we are adding 2 of the root 5s, then we're subtracting 1 of the root 5s, and therefore 3 plus 2 is 5. 5 minus 1 gives us 4 square root 5. So that's our solution, 4 square root 5. I hope all of us got that one right. Moving on to the next one. I know most of you are happy because we had looked at a question that was similar to this. We have a difference of 2 squares again. So if you look at this, all we need to do is to multiply the first term in the first bracket by the first term in the second bracket. So 3 multiplied by 3 gives us a 9. Then we move on quickly to the second term. The second term is positive square root 2. We're multiplying this by a negative square root 2. So remember our rule. If we have square root 2 multiplied by square root 2, this just simply gives us what is under the square root sign, which is a 2. 9 subtract 2 gives us a 7. Well done, grade 11s. I see that most of us are getting through this. But now if you look at the last one has got an n is an exponent. We also have the square root. So this one needs us to be very careful. Like I indicated, we need to first make sure that if I have more than one term, try to factorize so that you check if we cannot have factors in the numerator and denominator that we can divide. So if you look at the terms in the numerator, we have 2 raised to the power of n, and we also have 2 raised to the power of n in the second term. So the wisest option here is to first factor out the 2 raised to the power of n. And then in our bracket, we are going to have square root of 32 plus, because we have already factored out this 2 square root 10, the second term will be square root of 2. And then this is all divided by 2 raised to the power of n multiplied by the square root of 50. Now, like you see, we have a common factor, 2 raised to the power of n. So we're going to divide by 2 to the power of n, and then we're simply going to remain with our square root 32 plus the square root of 2, and this is divided by the square root of 50. Now, we need to simplify this further. As you can see, these sets are not simplified except the square root of 2. So again, we go through the same process. We write 32 as a product of factors. So 32 as a product of factors is 16 multiplied by 2. Then we have add square root 2. This is also divided by, we simplify the square root of 50. Square root of 50 becomes square root of 25 multiplied by 2. Right. I know some of us used our calculators, but it is fine. Make sure that you do not skip the steps that we have there, because remember our question said we need to simplify without the use of a calculator. So when we are using our calculator, it is just so that we can find the factors that we need to put under the square root sign. And you remember I said, if you simplify, if we take our calculators and we say square root 32, you will notice that the answer that you get there is 4 square root 2. So it means the 4 was repeated under the root sign. So 4 multiplied by 4 is the 16 that we have written there. So we now know that if I simplify the square root of 16 multiplied by 2, this gives me 4 square root of 2. Then I'm going to add square root of 2. Then this is divided by the square root of 25 is simply 5. Then the square root 2. Now, if you continue further, you'll notice that I've got like terms in the numerator. 4 square root 2 plus square root 2 gives me 5 square root of 2. I'm going to continue up here. 4 square root 2 plus square root 2 gives me 5 square root of 2. And then I'm going to divide this by 5 square root of 2. Now, this becomes much simpler because we know that if you're dividing anything by itself, your solution there will simply be equal to 1. I hope that we all managed to get this answer right, grade 11s. Now, we are going to move on and look at our exponents. We have dwelt so much on SEDS. And like I said before, it is not necessary at times to change our SEDS to exponents because we can work with the SEDS as they are and treat them as algebraic terms. Now, for an exponent, remember we have a base, like in our case here, x is our base. And then we have an exponent. Some people call this an index, right? Our index is y. The exponent or the index there tells us how many times the base has been multiplied. Say, for instance, if I have 2 raised to the power of 3, 2 to the power 3 means I'm multiplying 2 by itself 3 times, like this. Then when you simplify this, this gives you an 8. Remember, grade 11s, we cannot just multiply a base and its exponent. This, if you check, if you multiply 2 by 3 gives us a 6, but that's not the meaning of an exponent. So please really do be careful when you are working with your exponents. Right, there are so many laws that we have learned since we were in grade 7 and grade 8, and also followed through in grade 10. When we are multiplying terms with the same base, the simplest way to work with this, it will be to simply add the exponents. Say, for instance, if I have 3 raised to the power of 2, and then I'm multiplying this by 3 raised to the power of 2. Instead of expanding this like we used to do in the lower grades, we can simply take this to be 3 raised to the power of 2 plus 2, and then this simplifies to 3 raised to the power of 4. So please remember, these laws that we are learning now are going to be very useful for us when we are simplifying or we are working on our problems or calculations. The second one, we are saying if we are dividing terms with the same base, to simplify our work, instead of expanding again, we are going to subtract the exponents. So if I say to you 2 raised to the power of 5 divided by 2 raised to the power of, say for instance, 4, I'm simply going to take this as 2 raised to the power of 5 minus 4. And when we subtract 4 from 5, we're going to get 1. So it simply becomes 2 raised to the power of 1. But remember, when we have an exponent 1, we usually don't write the exponent 1 there. Right, that is the second law of exponents that you learned. Then the third one, we have, if we are raising an exponent to another exponent, when we are simplifying, we're saying that the easiest way to simplify this is to just simply multiply the exponents. So if you have 7 raised to the power of 2, again raised to the power of 3, this will simplify to 7 raised to the power of 2 multiplied by 3, and 2 multiplied by 3 gives us a 6. Right, then the last one there that you see, if I have different bases, please take note, we have A as a base here, and then we have B as a base. Then the exponents there, if you check carefully, are the same. We have exponent M. We also have here exponent M. The simplest way to work with this would be to multiply the bases, which is A multiplied by B, and maintain our exponent as M. So we would like to quickly verify this law on our calculators. Let us check. If I have 2 raised to the power of 3, then I multiply this by 3 raised to the power of 2. Right, when you're multiplying, remember when we are looking at exponents, 2 raised to the power 3 means I'm multiplying 2 by itself 3 times. And when we multiply this, 2 raised to the power of 3 gives us 8. Then I'm saying 8 multiplied by 3 raised to the power of 2. Remember, it's not 3 times 2, but 3 multiplied by 3. 3 multiplied by 3 gives me a 9. And when we multiply these two, 8 multiplied by 9 gives us 72. Right. Let us check how I got this. If I take 2 raised to the power of 3 by 3 raised to the power of 2, like I indicated, we're using our law. I am going to take 2 and then I multiply 2 by 3. Sorry, my apologies, grade 11s. Our exponent there is supposed to be a 3. But let us just continue and see what would have happened if I had worked it out like this. If I take 2 multiplied by 3, and then if you check, the exponents are not the same. And then if I decided, and I made this mistake, look at what is going to happen. And I said this is raised to the power of 3. This is going to become 2 times 3, which is 6 raised to the power of 3. And when you simplify 6 raised to the power of 3 on your calculators, grade 11s, what do we get? I know all of us have got it as 216, which is not the same answer that I got up here. Ne? So please let us be careful when we are using the laws of exponents. The exponent should be the same for us to be able to multiply the bases. So in my example, like I indicated, we were supposed to have 2 raised to the power of 3 multiplied by 3 raised to the power of 3. Then this can be simplified to 2 multiplied by 3 raised to the power of 3. And we all know that 2 multiplied by 3 is 6. And this 6 raised to the power of 3 would definitely give us 216. I hope that all these laws, with practice, we all know what to do next time. Then, as a rule, we all know that if I raise anything to the power of 1, my answer will simply be the same as the base. Right? There is another set of rules that we should remember when we are working with the exponents. If I have a negative exponent, I can change the form of writing x to the negative n and take the exponent to the base, and then the sign of our exponent changes from a negative to a positive. But remember what we said when we started, our base cannot be equal to 0. And then also by definition, anything raised to the power of 0 will be 1, except 0, because if you say 0 raised to the power of 0, even if you check, it will say an error or undefined, because we cannot raise 0 to exponent of 0. Now, enough of the laws. These are the laws that we have learned since the previous grades, but we now were introduced to rational exponents. Like I said, rational exponents are simply telling us that instead of having an integer in our exponent, we now have a fraction. Now, when we are simplifying expressions, we need to be able to move from one form to the other. If you look at these two, they are exactly the same, but they are written differently. What they simply mean is that, for instance, if I have the square root of 2 cubed, this is the same as writing it as 2 raised to the power of, remember, you take what is the exponent which is under the root sign, you write it as your denominator, and then you divide by the number that is outside the root sign. But in our case, because it is square root, our denominator there will be a 2. Now, when we're simplifying this, we need to work with it one at a time. That is why you see that in the second part of our rational exponent rules, what you do first is you are going to say square root of 2. The square of 2. Then after finding the square of 2, remember the square of 2 is 4. Then you are going to find the cube root. So if you check carefully, I cannot find the cube root of 4. So in this case, I would have left my answer as the cube root of 4. But there are questions where you will be able to simplify further. So when you are applying this rule, please be careful. You can either first find the solution after finding the exponent before you find the square root, or you can work with it vice versa. Then again, if you check in the next rule, if I have the root of A multiplied by the nth root of B, I can make my calculation easier by just simply multiplying the terms under the root sign. Right, this is applicable especially in cases where, for instance, you will not be able to find, say for instance, if I say the square root of, say for instance, 2, then I say I want to multiply this by the square root of, say for instance, 8. We can all see that I cannot find the exact value of square root 8, neither can I find the square root of 8. But if I take these two and multiply them together, 2 multiplied by 8, 2 multiplied by 8 gives me 16. And the square root of 16 gives me 4. Now, you have seen that in the first instance, we thought we could not find this solution to this question, but we can do that after we have used this rule. Grade 11s, please take note. At times, it is wise or it is advisable for you to always check your solutions on the calculator to see if these rules work. Because at times, we tend to create our own rules and we find ourselves in trouble. Right, the next one is dealing with division. Like the previous slides when we had, we're working with the sets. When we are dividing and then finding the root, we can split the expression by saying the nth root of A divided by the nth root of B. How is this possible? Say, for instance, if I have the square root of 32, and I'm going to divide this by the square root of, say, 2. This can be changed from this form. Remember, if I have a division sign, I can write it as the square root of 32 divided by the square root of 2. And if you check carefully, I cannot do anything here unless if I will first simplify my expressions. But I can also make my life a little bit easier by just making sure I take those two numbers and put them under the square root sign, and then I divide. When I divide 32 by 2, my answer there is 16. So the square root of 16, as you can see, will give us a 4. Right, the last one there, again, if you are finding the root of the mth root of the nth root of A, my work at times you would say, my goodness, how am I going to do this? But say, for instance, I had square root of 2, and then I say I want you to find the square root of 2. Let's say I want you to find the square root of the square root of, say, for instance, let's change this number to 16, not 2. The square root of the square root of 16. First of all, I was going to find the square root of 16. The square root of 16, we all know, is going to be a 4. But remember, I have another square root outside, so it will be the square root of 4 again. And the square root of 4 gives me a 2. Now, instead of having to do all this work, we are saying that rather multiply the roots that you are looking for. So in our case, I'm going to say there is an imaginary 2 there. There's also an imaginary 2. So if you multiply 2 by 2, this gives us 4. So I'm trying to look for the 4th root of 16. We are saying what number multiplies itself 4 times to give us 16. And if you check again, like I said, with your calculator, you'll find that this is going to be 2 raised to the power of 4. 16 is just the same as 2 raised to the power of 4. So the fourth root of 2 to the power of 4 simply becomes a 2. Now, grade 11, this is so much of rules, but our work really lies on us working with examples. So let us move on to the next example. The first example, there is something that you were probably introduced when you started with exponents and seds in term 1 of this year, right? If I'm asked to simplify 8 raised to the power of 2 over 3 without the use of a calculator, you will notice there on the right, I've put something to make sure that if I see a question, I'll be able to quickly check what is it that I need to apply? What rule am I supposed to use? Even when you are working, you know that if I do not follow these rules, I'm going to end up in trouble. So let us look at this rule that we are talking about. Remember, I said if you have a fraction, it means that there is 2 operations that you need to work with. I'm finding the root, and then I'm going to find the exponent. So in this case, I'm going to split my exponent and write this question as the third root of 8. This I'm going to do first. That's really the reason why I'm putting it in brackets, and then I'm going to square. Now, all of us know that if I'm trying to find the cube root, we're asking ourselves what multiplies itself 3 times to give us 8. And we all know that this is going to be 2 raised to the power of 3. And then I square this. Now, if you have the cube root of something cubed, your answer, which is a rule that you can also learn grade 11s because it's going to assist you, your answer there will be simply a 2. Then 2 to the power of 2 gives us a 4. The alternative way that I could have worked this out was I would first find the square of 8 before I find the cube root. So we all know that if I square 8, 8 times 8 becomes 64. And then the cube root of 64, we all know the cube root of 64. If you check, like I said, those who are very hesitant when it comes to factors, just punch into your calculator cube root of 64. Cube root of 64, you will see will give you a 4. So you know that the 4 was repeated 3 times under the root sign, and therefore your answer there is simply a 4. I hope that we are all following the examples carefully, because now they are getting a little bit complicated and we need to apply more rules as we work with our questions. Right, example 2, we have -2 multiplied by the fourth root of a cubed, and all of this under in the brackets is raised to the power of 8. Now we cannot simply work this out in one step, and like I said before, please make sure that you have your necessary tools. Look at the tools that I've put there on the right. The first rule says, if I'm multiplying terms with different bases, as we all can see, I have -2. It is different to the second one there, which is a fourth root. So when I'm multiplying terms with the same base, with different bases, remember we said we can split them and write the same exponent. So that's what we're going to do first. We are going to take -2 and raise it to the power of 8. Then this is going to be multiplied by, we have the fourth root of a to the power of 3. The fourth root of a to the power of 3. This should also be raised to the power of 8. So we are working with this law in reverse. This we should also make sure that we are able to do comfortably grade 11s because it assists us with our calculations. Then -2, please take note, needs to also be put in brackets, because if you do not do that, you are going to end up with an incorrect solution. So -2 raised to the power of 8, although we said without a calculator, I know some of us struggle without using the calculator. Quickly take your calculator and say 2 raised to the power of 8. Now, if you take 2 raised to the power of 8 on the calculator, it gives us 216. And then the second one, we need to make sure that we are going to change the root sign and express this term as an exponent. And how do we do that, grade 11s? We are going to write this as a raised to the power of, remember, the exponent under the root sign first, divided by the number you see outside the root sign. This is a 4, so our denominator there is 4. And then we are raising this to the power of 8, right? So this is the rule that we have just applied there. We are changing from the root sign to exponent form. And then to simplify this further, we are going to end up with 216. We have already simplified this. And then we apply the last rule there, which says if I'm raising an exponent to an exponent, I simply multiply the exponents. So 3 over 4 multiplied by 8 gives us a raised to the power of 6. So our solution there is 216 a raised to the power of 6. I know at the beginning, most of us were saying now this is becoming complicated. But remember, grade 11s, we, especially with our technical subjects, we are all working with different trades, and we need to be able to manipulate whatever we are given so that we come up with something that people will say, wow. Right, let us move on to the third example. Right, the third example looks very simple. But then the problem that we have there is that we have the cube root of 4. And we all know that the cube root of 4 does not give us an exact solution. Also, if you look at the cube root of 16, we do not have a number that multiplies itself 3 times to give us 16. So the only way I'll be able to simplify this is to apply this rule, which we said you take the terms under the root sign. Why am I taking the terms under the root sign? It is because we are finding the same root, the nth root. So in our case, we have the third root here. We also have the third root there. So if that is the case, then I am allowed to combine those two by multiplying 4 by 16. And when I multiply 4 by 16, please check with me, grade 11s. What is 4 multiplied by 16? I'm sure all of us, they have written the answer is 64. Right, now what multiplies itself 3 times to give us 64? Like I said before, let us check again with our calculators. I know it's monotonous, but at times it saves our lives. This becomes 4 raised to the power of 3, because when you say cube root of 64, on the calculator it says 4. So it means 4 was repeated under the root sign. So we can apply this rule, which says that if I have the nth root of a raised to the power of n, this is simply going to be equal to a. So in our case here, our answer is 4. I have done a lot of talking, grade 11s, but we still have one more which we need to apply. There is one thing that we did not discuss at the beginning of the lesson. What happens if, for instance, I now have addition or subtraction under the root sign? Right. In this case, we cannot apply the laws that we have just talked about. We need to first make sure that we simplify as far as possible what is under the radical sign, because it makes our calculation easier. So to simplify this question, I will use the rule that you see on the right, but at the same time, I first need to make sure that I simplify the denominator. So in my first step, I'm still going to write the cube root of 8 raised to the power, or 8x raised to the power of 6, and then this is divided by, to simplify this, you see that these two are like terms. We have x squared there, we also have x squared. So 16x squared plus 9x squared gives us 25x squared. Now this is simplified enough. Before we can apply this rule, right now the rule says that, remember, if I am taking the same root of different terms, I can combine them. But now in our case, they are already combined. So it means we need to work in reverse. So what am I going to do? Here I'm first going to split these two. So I'm finding the cube root of 8. Then I'm multiplying this by the cube root of x to the power of 6. And then in the denominator, I have the square root of 25. And I'm multiplying this by the square root of x squared. Right, now when I'm simplifying this, remember we said the cube root of 8, by now all of us know it's going to be 2. Where did the 2 come from? Our rule again, which said the cube root of 2 raised to the power of 3 multiplied by this. I'm now going to change. Remember the rule the law that we talked about there. If I have a cube root of something with a power, I am going to rewrite this as x raised to the power of 6 divided by 3. And then in the denominator, for the square root, I'll have square root of what number multiplies itself? It's 5. And then here again, I'll change this to an exponent. This becomes x raised to the power of 2. And then this is divided by 2. Why did I decide to leave the root sign for the numbers? It is easier if I work with this because I know that this is coming from the calculator, although we said not using a calculator. Right, now when I simplify the numerator, I'm going to end up with the cube root of 8 is 2. Then this is multiplied by x. 6 divided by 3 is 2. And in the denominator, I'm going to have 5. And then 2 divided by 2 there gives us just 1. So my answer there is 2x squared divided by 5x. But we are not done. We still have terms with the same base there. So I am going to write my answer as 2 divided by 5. Then using our law of exponents, remember our law of exponents when I'm dividing terms with the same base. So x to the power of a divided by, say, x to the power of b. This is the same as saying x to the power of a minus b. So in our case, I'm going to say x to the power of 2 minus the exponent there. If you don't see an exponent, remember it's 1. So 2 minus 1 simply gives me 1. So my solution is simply 2 over 5 multiplied by x. That was a mouthful, grade 11s. Now it is your chance to try out the examples that follow. I am going to give you again another 3 minutes. Welcome back, grade 11s. I hope you had enough time to look at the two questions. Right, looking at the first one, we have, again, if you notice carefully, there are two terms under the, before we find the cube. So we need to split this using our rule. Remember, if I'm raising an exponent to an exponent, but there are two terms, I first need to split the terms under in the brackets before I can simplify. So we're going to say 2 raised to the power of 3 multiplied by the second term, which is a to the power of 7 divided by 3, also raised to the power of 3. Then we all know that 2 raised to the power of 3 is 8. Then when we multiply 7 over 3 by 3, remember some of us get confused. Let's write 3 as a fraction. This becomes 3 over 1. And then when we simplify this simply becomes a to the power of 7. Well done to those who have managed to get this question correct. Now moving on to the next one. The next one is a little bit involving because we need to multiply, we need to add. So let us work with it slowly. If you look at the second term, we have the cube root of 9. Then we need to square the cube root of 9. So I'm going to write this as 7 multiplied by the cube root of 9. Some of us are already telling us that we cannot find the cube root of 9. So in this case, it would be easier for you to write the square of, find the cube root of the square of 9. And then this is divided by, if you check in the denominator, we have like terms there. So there is no need for us to find the cube root of these two terms because it's going to make our working a little bit messy. So rather, let's just add these two like terms. So it's 1 of the cube root of 81 and a 7 of the cube root of 8. So when we add them, I'm going to end up with 8 cube roots of 81. Right, now the square of 9 there gives us 81. So this becomes 7 multiplied by the cube root of 81. And then this is divided by 8 cube root of 81. Now hang on. If you look at this question, we now have two terms or two factors that look identical in the numerator and denominator. So it will be a waste of time for us to now try and look for the cube root of 81. So the easiest way out there would have been to just divide these two, and then my answer would simply be 7 divided by 8. Please take note, grade 11. Some of us, I know, have already cheated and got the answer 7 over 8. But remember, you need to show all these steps for you to get full marks, because just an answer at times will not give you any marks. Right, now we would like to move on to some other questions that we also see in our examination papers, which deal with exponents. Now, in this question, we no longer just have numbers as exponents, we now have variables. And again, we also need to apply our laws of exponents at times in reverse for us to be able to get our solutions. And remember what we said, if you see that in your numerator or denominator you have got more than one term, you need to first try and find out if you don't have a common factor. Now, before we start with this question, I want us to identify, do you think we have a common factor here? Yes, I see something. We have a base 2 here. I also have a base 2. Then there's an exponent x, exponent x. The same applies in the denominator. I have base 2, then there's an exponent x. So the first thing that I'm going to do here is I'm going to try and factorize the numerator. Now, how do I factorize the numerator? The first thing is, let us split this exponent here, and also let's split this exponent here using the reverse rules of exponents. So we're going to write 5 multiplied by 2 raised to the power of x. Remember, if I'm adding the exponents, it means that before I simplified, I was multiplying terms with the same base. Our base here is 2, so this becomes 2 multiplied by 2 to the power of x multiplied by 2 raised to the power of 3. Then I say subtract 3 multiplied by 2 raised to the power of x, and this was multiplied by 2 raised to the power of 2. And then I divide all this by 2 raised to the power of x. Again, I'm splitting this to 2 to the power of x multiplied by 2 raised to the power of 1. You can write the 1, but remember grade 11s, you do not necessarily have to write the exponent 1. Now, our common factor, like I said, you can see that there is a minus between these two terms. 2 raised to the power of x is common. 2 raised to the power of x is common. I also have another common factor, but I'm not going to worry about that for now, because the first thing that I need to do is to get rid of that exponent with a variable. So I'm going to take out the common factor, 2 raised to the power of x, and what is going to remain inside the brackets? Remember, this now has been taken out, so what's remaining there is 5 multiplied by 2 raised to the power of 3. And we all know that 2 raised to the power of 3 is 8. Then I say subtract. I've also taken out common factor, which is 2 to the x. Then this becomes 3 multiplied by 4. And then I'm going to divide all this by 2 raised to the power of x multiplied by 2. Now, when I divide these two, I'm going to remain with what is inside the bracket. But in the bracket, we have 5 multiplied by 8. 5 multiplied by 8 is 40. Then I'm subtracting 3 multiplied by 4. 3 multiplied by 4 is 12. And then I'm going to divide this by the remaining factor in the denominator, which is 2. 40 minus 12, grade 11s. What is 40 minus 12? I'm sure we have all used our calculators there. Our answer is 28. So I'm going to say 28 divided by 2. And what is 28 divided by 2? This gives me a 14. Wow. We are done simplifying. From that complicated, complex expression, our answer gave us simply a 14. I hope you were able to follow this through. Now it's your time to show the skills. Remember, we need to make sure that everything that we do, we are going to be able to work with this. So I'm just going to give you a minute to work through this to see if we can get our solution. Welcome back, grade 11s. I hope you managed to work on this question quite quickly. You already noticed there we have a common factor. Yes, the common factor there is 3 raised to the power of x, because you can see it in all the terms that we have in our question. So we are going to try and make sure that we split the second term there, because we have 2 terms in the exponent. So this is 3 to the power of x multiplied by 3 raised to the negative 2. And then this is divided by 3 raised to the power of x multiplied by 3 raised to the power of negative 2. Now the next step was to take out the common factor. The common factor in the numerator is 3 raised to the power of x. And then when I take out 3 to the x, most of us do this. then we are remaining with nothing. But remember, we are looking at factors. So I'm asking, what do I multiply by 3 raised to the power of x to give me 3 raised to the power of x? And we all know that this is 1. Then I subtract. I'm taking out this factor again. And what is remaining there is 3 raised to the power of negative 2. But like I said, negative exponents can be changed to positive exponents. So I'm going to quickly write this now with a positive exponent. This is 3 raised to the power of 2. Now, the 3 raised to the negative 2 became 1 divided by 3 raised to the power of 2. And in the denominator, we have 3 raised to the x multiplied by, I change this again to 1 divided by 3 raised to the power of 2. Now, these two are going to divide, and then I have 1 subtract 1 divided by 9. And then I'm going to divide this again by 1 divided by 9. Now, again, like I said before, even it says without a calculator, you can check with your calculator. 1 subtract 1 over 9 gives us 8 divided by 9. And then I'm dividing this by 1 over 9. And then we know that when we are dividing with a fraction, we change this to a multiplication sign. And then this becomes 8 over 9 multiplied by 9 over 1. And clearly our answer there is 8. Right. This is another form of question that you may encounter grade 11s. So in this case, please take note that I have 6 to the power of n, 3 to the power of n. It seems like we do not have a common factor. So the first thing that you need to do is to split the base to prime factors. What are the prime factors that multiply to give us 6? We know that this is 2 multiplied by 3, and we raise this to the power of n. Both of them are raised to the power of n. We are applying our law of exponents in reverse again. You remember when we have a multiplied by b raised to the power of n, we can simply write this as a times b to the power of n. So I have split these two. We have split 6 to become 2 to the power 2 times 3, and then the next one we already have prime base 3, so it is 3 raised to the power of n multiplied by 3 raised to the power of 1. Then we divide this again. 4 is not a prime base, so we change this to 2 raised to the power of 2, but be careful there, we still have an exponent n. And then again minus, we also can change this to 3 raised to the power of 2. And then we are going to use our law of exponents. If I've got 2 terms raised to a power, I can write this as 2 raised to the power of n multiplied by 3 raised to the power of n. Then I have my plus 3 raised to the power of n multiplied by 3 raised to the power of 1. And then this is divided by our law of exponents says if I'm raising an exponent to an exponent, this becomes 2 raised to the power of 2n minus 3 raised to the power of 2. Now, there is a common factor there. I have 3 to the n, I have 3 to the n. I also notice that in the denominator, I have 2 to the n, but let's not worry about that now. Let us try and take out the common factor there, which is 3 to the n. 3 to the n is a common factor in the numerator, and what's remaining is 2 to the n. Then since I took this out, I now have plus 3. And then in the denominator, if you check, do I have a 3 to the power of n? No. What do I have? I have 2 to the power of 2n minus 3 squared. Now, how do I simplify this further, grade 11s? I need to check in the denominator, I have a difference of 2 squares. This is 2 to the power of 2n. This is 3 to the power of 2. So this term can be factorized. So please take note, at times when you're stuck, the easiest way out is to check, can I not factorize this? So I already identified that this is a difference of 2 squares. I'm going to write this as 3 raised to the power of n multiplied by 2 raised to the power of n plus 3. And then when I'm separating or I'm trying to find the factors of a difference of 2 squares, I'm going to end up with 2 terms or 2 brackets with the same factors. So 2 raised to the power of 2n is the same as saying 2 to the power of n multiplied by 2 to the power of n. And then the second one will just simply give us a 3. So remember, if it's a difference of 2 squares, same factors, but different signs. Then look carefully now, grade 11s. I have a common factor, 2 raised to the power of n plus 3, 2 raised to the power of n plus 3. Now, when I divide this, I'm simply going to have my solution as 3 raised to the power of n divided by 2 raised to the power of n minus 3. Well, grade 11s, as we continue with our work in technical maths, we'll see that the questions there become a little bit complicated. So we need to know how to work with our questions and use the rules, laws that we have learned even in previous grades. Now, I'm going to leave you with a challenge. Please take down this question. The solution is already there. This is another type of question that you may get when you're working with your final exams next year. We have a fraction which simplifies to the square root of 3. So please try and do that on your own. I hope that you all have managed to copy this question down, or if you've taken a screenshot of the question. Right, grade 11s. Thank you for watching this lesson. Please remember to sanitize, wear your mask, maintain social distance, and keep safe. See you on Friday. Goodbye.